Sorry?
Go to the audience, or will you pass the microphone to the
I will.
audience? Oh, okay.
Okay, welcome everybody. This is the conversation time with Marsha. To the gentleman who's just taking off his jacket, you are my special guard in this session. Nobody's allowed to sit higher up in the room than you are. If someone goes sit there, you need to go tell them that those seats are 200 euros an hour, okay? And then we'll split the income between you and me. But the idea is a little bit that this is slightly more intimate, so I'll sit down. That this is an opportunity for you to explore some of the themes that Marsha talked about in the opening keynote. I'm sure that you can ask somewhat more wider-ranging questions as well. Those are the rules, which is as much as saying there are no rules. You can ask whatever. I'll pass the mic around because otherwise, if there's a question from over here, people over there don't hear the question. And with that, I think we can get started. Who wants to ask first question? And by the way, we have some very special guests there who just wanted to see what a conference looked like. So if you want to, you can sit here for a minute or two.
Thanks. You showed a slide somewhere in the middle of your presentation about the extent to which learners had been engaged in practicing skills of argumentation, picking out various kinds of information and so forth. Could you describe more about that and others of the so-called clickstream data that you're collecting and the ways it feeds into the models of skills you're looking at?
Absolutely. So one of the things that someone else mentioned is that a lot of this kind of work has been done in mathematics and objective domains. We have been working with course authors and instructors in instrumenting their courses when the content domain is something like English. The activities in those cases range all the way from quick comprehension check questions. So if students are working online and learning about what are distinguishing features of a claim versus a preference or an opinion, things like that. What's evidence versus a claim? There could be some short comprehension check questions. There could be some intermediate complexity questions where students have to apply those new concepts in context and maybe recognize a claim. So you could have a bit of text, and the student then interacts with the text to basically analyze it with the computer, giving feedback on that process. We also want to make sure that all the way to an English paper, some kind of information from that could feed into our system. And in the case of the fully, term paper or essay assignment, the main way that we see it tying in is via rubrics. And so I'm a real fan of rubrics, and I think this is another maybe incentive for faculty to think about being clear about their values and expectations when they assign more complex work. When the student completes the paper, the multiple different ways of doing it. You could even have peer review using the rubric. You could have the instructor or the TA fill out the rubric. Then what we do is we map each row of the rubric to the set of skills that would support performance on that aspect of the paper. Does that answer the question?
Thank you for the well-done presentation. I really enjoyed it. I'd like to hear a little bit more clarification about what you mean by the learning state. Initially, I thought that's about how students understand and go through the learning processes. But it seems that the system seems to be heavily focused on skills. And skills are related to understanding, so it's not mutually exclusive. So I really want to know what you mean by learning state from that sense, because in the United States, there has been some kind of national agreement to shift from skill to understanding, especially in mathematics education, in terms of common core standards. So I'd like to hear a little bit more clarification about that.
Thank you. I'm so glad you mentioned that. I am using the word skill in a very broad sense. So I do not mean just isolated computational kinds of knowledge. I should have used a more generic term, probably, like a knowledge component. The reason I pick between those kinds of words when I talk about my work is something like understanding is big and amorphous. And what makes it really challenging is it's also ambiguous. So what I like to do is move faculty from thinking about understanding and not pinning it down to what they expect students to be able to do with that understanding or the consequences of that understanding, and help them think about the understanding in terms of how it is expressed, its components, if they're thinking about the learning trajectory to reach understanding. So yes, I'm definitely looking at this in terms of the goal of understanding, but I purposefully avoid that word because it tends to lead to ambiguity. In fact, with rubrics, that's one of the advantages of rubrics, is that it makes more precise the communication between students and instructors. So in terms of the learning state, to get to the other aspect of your question, you can think of it as for each piece of knowledge in the domain, whether that's conceptual knowledge or procedural skill or knowledge of relationships between components in the domain, we're estimating a quantity that is the strength of students' knowledge of that component, sort of the strength of that knowledge component. And that's what we're trying to communicate back to students and instructors. It's not just how much students have worked on activities. It's not just how many times have they done some problems or how correct they've been, but it's the inference to the latent variable of really their understanding or their strength of knowledge of a given concept. And in the talk, I emphasize the idea that over time, this learning follows a power function. And so I was showing it this way with errors. You could also see it going this way with latency, like time to respond would go down. In terms of the strength of learning, you can think of it as a power function going this way. So still, early on, there are large increases, and then there's asymptotic, marginally decreasing return. In addition to that power law function, we can also bring into the modeling things like decay, so that if students are doing a lot of activity in one conceptual space for a while, the model will estimate their learning is very high for that set of concepts. But then if they move on to some other concept area that is not so related, so it's not activating those older concepts, then the knowledge state estimate will go down just by inactivity. However, if in some areas it's very cumulative, so as students go in later topics in the course, they're always practicing the other material. So in that case, it would not show that decay.
It's also allowed to ask a question from further down in the room, but I'll first take these two.
David Rudel, I'm from Explore Learning. Have you suffered any criticism from this purely quantitative, continuous representation of learning state as opposed to, say, a categorical one? An example that I have in mind is you can talk about your understanding of a certain concept, say Pythagorean theorem, okay? So that's a concept, it's a pretty important one. And you can have a knowledge of a Pythagorean theorem in terms of its ability your ability to apply it when necessary. But you could also have what I think some people would consider a deeper visceral understanding or capture of the Pythagorean theorem to know when to apply it or to identify problems where it's applicable, identify problems where it's not applicable, and so the type of problems that would be necessary to test that would be different. The error rates for one might have no representation, no reflection of the error rates of the other. I'm just wondering if this notion of learning state really needs to be more of a categorical question or discrete rather than a continuous quantitative.
Actually, I'm glad you gave that example. It's a perfect one, and it relates to examples that I've given. If you think about Pythagorean theorem as the concept, and you could think about what is students' understanding of this concept. Actually, the examples you gave of the different interpretations would be the components, in my analysis, of that larger concept. So it could be that we could track how students are able to calculate a squared plus b squared equals c squared. It could be that we can track when they're solving problems, do they apply and draw on the knowledge of the Pythagorean theorem when it's relevant. It could also be that we track, are they able to explain why it's true? Even are they able to prove it, or by how many methods? And so that constellation of smaller components of knowledge together make this emergent understanding of Pythagorean theorem. So in the system that we've built, each of those components we track individually, knowing that in many cases they're applied together. Then we also have in part of the skill map representation something that an instructor or an author of online materials could represent those interconnections. We can also then use the data to have sort of a posterior probability of the relationships between those concepts. And then what you can do is look at the aggregate learning state over that constellation. So it's a way, the idea is to make this flexible, to accommodate complex constructs like this that have a lot of different parts, and then we use the same metric, learning state. We just then consolidate it based on the representation. And that's a representation of the interconnections that could be user-specified, but also revised based on what we see in the data.
Carlos Monroy from Rice University. I had a lot of good ideas from your presentation for the work we're doing on a K-12 science curriculum and dashboard. My question is, this requires access to computers, and especially in higher education, so you have one-on-one. How do you see this getting into K-12 where the reality is very different? I think that at some point we will get there, but how do you make sure about that the models are correct? How do you build these models when the level of interactivity of the students with computers is not as it is the case in higher education? And the other part of the question is, when there's activities that are not necessarily recorded by a computer. So if you are doing an experimentation in science, which is the case of our curriculums, how do you account for that?
Right.
Thank you.
Great question. So I have focused on the easily collected, automatically collected, computer-mediated data. A lot of the learning environments with which I work are online courses or online modules in higher education. But we need to think about how these methods can apply more broadly. I think there are a few ways that we can see this approach, and in general, I think all of our approaches reaching out to that K-12 community. One is through mobile devices and how much more they are being used in inquiry science as sort of a lab recording device. Could also be an interaction with the, there are fancy applications to connect your smartphone to be part of a sort of instrumented chemistry lab for younger students. You could also imagine on that mobile device some interactive elements. And if those kinds of mobile device activities could also be generating some stream of data, that would be very great. In classroom interactions, well, one thing I was going to say may not apply, but I would like to see in even the college situation that a blended learning environment could tap into the class-based data as well as the online-based data and merge those two. So if a classroom is instrumented with clickers or personal response systems, those data could feed in and be aggregated in the larger analysis. I don't think that's very common, though, in K-12. So I think the approach that I see on the horizon would be much more for the finding ways for the artifacts of students' work to be, and this is qualitative data, right? Finding ways for those qualitative artifacts to be processed and somehow fed into our systems. So it may be that in more of the technical areas where students are already more likely to be working with computers in the schools, we'll see those first. I don't know. Or maybe if they're using, in high schools, maybe more these days, they're using Google Documents and things like that will have easier access. But when they're paper artifacts, that will be a big challenge, I think, or classroom-based.
Linda Baer, I'm at Minnesota State University, Mankato. I have a question about your role in the Teaching and Learning Innovation Center, and the idea of this dashboard is wonderful. Do you have examples of how faculty are beginning to accept and adopt this tool?
One of the big questions with educational technology is the researchers love it, and when they work in their first pilot study very intensively with faculty members, everyone loves it. But the question is, how does it go much broader than that? And I think that is going to be an ongoing piece of work, which is why I'm really glad in my role to sort of not just be in the researcher position, but thinking always mindful of how are faculty going to adopt this and adapt it to their practices. I mean, like I mentioned just a moment ago, we put a lot of money into instrumenting 2/3 of our classrooms with personal response systems at Carnegie Mellon. I know a lot of universities who have done that. You might wonder how many faculty members at Carnegie Mellon are actually using these things. And then you might ask the further question, how many are using them really effectively and efficiently in their teaching? And I think the answer is not as optimistic as you would hope. So I think if we can go in much more proactively in designing these systems with users on our teams. So one of the things that we've done is we've had a very multidisciplinary team. I think it fits with the theme of this conference. Learning science, statistics, data mining, human-computer interaction, design, and faculty members, folks who are going to be using it. What I would like to see more of is that we have students participating in our design with us. Haven't done that so much yet, but we're gearing up to do that more. What it also means is that we need to think about building the tool, but also building the support around the tool. So a lot of educational technologies that have been more successful, I think, is when they have continuing professional development for users, when they have support tools for users, and that is what I think we'll be doing at Carnegie Mellon more and more. And, well, now I think we have one other positive advantage in adoption and adaptation, and that is we're seeing faculty networking a lot more. We're even seeing K-12 instructors networking with each other a lot more. So there may be community of use leverage points.
Hi, Fred Galloway from the University of San Diego. I have a kind of a broad-based question for you, and it's really about the limits of learning analytics. And I was struck by the question in your general session about ultimately perhaps analyzing clicking behavior could maybe one day replace standard assessments. And I'm thinking I'm a mixed methodologist, somebody who spends life loving quantitative work, but it's really come to mixed methodologies. Now, you spoke about some qualitative work. I was really pleased to hear you say that. But I'm also, in this gathering, I think we can often tend to a little bit of hubris about what we can do. And so I was just curious on your thoughts about the limits of predictive analytics or of learning analytics.
Well, I think it's a very good question. I've been thinking about this question a lot more in terms of what are the limits of even broader educational technology. And I think a lot of us now are saying, wow, you know, we can be productive, more productive in our roles as educators if we move online, or we can be seeing things go to scale. I've been working with a lot of faculty members who are moving their courses or pieces of their courses online. And so I've been thinking about it a lot from that perspective. One thing that's been striking to me is that, and I hate this word, but I'm going to use it anyway, is the soft skills. Where are they getting translated in this conversion? So if I apply this concern I'm having in if someone is running a discussion class and they're translating a part of that online, or even a kind of a technical course like economics or economic modeling, I've watched a faculty member lecture or have a problem-solving recitation with students, and a lot more is going on than teaching the material. So it's in those other areas where I think we do need to be wary that those things are not getting, they may be getting lost in translation, as it were. So I've been thinking about how to capture those aspects and document, sort of articulate what they are so that we can then get at the problem of then can we cover them? Do we want to cover them in these new methodologies? Or do we need to invent new spaces for interaction and for tackling them? So I think one area where I think we do need to be quite wary is in the interpersonal communication, but those soft skills. So learning what it means to be, to think like an economist, learning to discuss, have a good heated but respectful conversation with a colleague. A lot of that feedback happens in our classrooms. It's not that it can't translate, but I think we do need to be wary and aware. So that's just one area. I'm curious what others are thinking of in this, you know.
I was thinking about the emotionality in the classroom. How is that captured? How do you see it captured? How can
Hi, Sean Goggins, Drexel University. I'm going to try to frame this question in a way where I think there's dissonance in a lot of people who study learning or across this community and others between the different theories that we apply when we think about how learning takes place. And those theories, of course, influence the units of analysis that we use, and they influence how we design both the technologies and the pedagogies behind the learning that takes place or that we're trying to guide. And I am more of a social learning theorist myself, and the dissonance I have is that a lot of learning, I think, philosophically and theoretically that I apply in my own studies and designs is focused on small group learning. And the things that I gather in the analytics are very different than the things that you describe. So instead of having, there's a preset learning outcome in the curriculum, but where those signals might exist is in interactions between small groups in a technologically mediated setting. And that's going to lead me to measure different things to some extent and present a different kind of dashboard than what you describe. And so I'm just curious about what your perspective on these dissonances that are driven by the different theories that we apply to measuring learning and giving students and teachers some kind of analysis of what's taking place. I hope that was a question.
Absolutely. I think I have two comments. One is that I think the underlying theme and my deeper value in all of this is, regardless of the metrics, regardless of the philosophical perspective and the theory to which each of us subscribes in terms of learning mechanisms and so forth, what I would like to see the learning analytics field embrace is those theoretical models. So rather than just looking at the behavioral data and doing data mining to get good prediction, whether it's sort of my theoretical framework or your theoretical framework, each of us has a model that we're subscribing to, that we're testing, and that we're refining with the measures we use. I would like to see all of those models be more injected into the data analysis of these big data sets. I think that can be helpful to, well, to the learning analytics, but I think it can also be helpful to the theorists to see those abstract constructs sort of operationalized and mapped out through those interactions. So I think in that sense, I'd love to see you use the same approach at that deep level, even though it might look very different in terms of the more cognitivist versus, social constructivist, however you want to label camps. I mean, I'm actually much more Catholic in my pursuits than this one piece of work might reveal. But I think that would be my real hope, would be to see that kind of infusion of the theory into the modeling efforts. And this is really, I think, where big data, it came in one of the questions earlier, where big data is maybe pulling us away a little bit from taking these theoretical models and taking the work to interface it with the large data sets. Because you can, the bigger your data set, predictive modeling can get you a long way. So that would be my first question. And then my second question, my first response. My second response, I guess, would relate to that taking a sort of individual approach. I think there are still, in what I was talking about, was all sort of the individual student is working in this online learning environment. I think there are a lot of opportunities for this particular approach to still pick up on variables from the collaborative or group, mediated by the computer learning philosophy or learning approach. And some of my colleagues have been doing work in the same vein, but those are folks who are in the collaborated learning community. So I think sort of at the high level, I think it can work, but really what I think is at the deeper level, I would like to espouse this sort of perspective. Thanks.
Son Latour, University of Amsterdam. I think to slowly also to pick up where you started on the social aspect of learning, but perhaps more on the implemented or practical technical part. How either now or in the future do you plan at curriculum development to sort of take that as a unit of analytics, this group collaborative learning part? How to analyze that?
So one of the ways would be to think about, are there collaborative learning strategies or team-based approaches that we can pick up on through some automated discovery of the interaction is signaling congruence of opinion. So let me back up. One of the things I think we'll have to do is we'll have to rely on more automated approaches to process those interactive data. So if a student is doing chat with another student, there are now some really nice automated systems that can pick up on features either of how the student's interacting with another in kind of some of these emotional, social-emotional aspects. Are they showing sarcasm even? And so we have detectors for these things. I can imagine pulling that in to the future work. And then I also think we could look at the processes of the learning that the collaboration is fostering or not, and try to get at not just individuals' metacognitive skills, but at the pairs or or the groups sort of productiveness as a learning community. And if we could have applied there, so there are models of collaborative learning, right? There are models of metacognition. If we could use those models to inspire the metrics we were looking for, that I think would be a really nice approach. And I think that there's already work in that direction.
Hi, thanks a lot. Alyssa Wise, Simon Fraser University. And I had a question that was similar to some of the stuff Sean asked about, so I was pleased to sort of hear your comments about the importance of theory and testing theory through analytics, even if it's a different theory than you're talking about here today, because I believe strongly in that, even though I might use a different theory. But that's also raised some tensions for me, so I want to kind of bring this question up to a higher level and ask if you've thought about these things too, which is, in my perspective, any analytics system that's doing a good job in helping us understand something meaningfully about learning has to have this underlying theory, and thus it's inherently going to have theoretical assumptions built into the system. And so, it's making statements about what we believe learning is. And that raises questions, I think, for this notion of adoption that had come up earlier in terms of, getting people to take on integrating a system, because in some cases it's not adding something to what they're doing, but it's asking perhaps for a fundamental change in how they're thinking about learning and for their pedagogy, both in terms of how they're teaching, but also in terms of what kinds of data in what sizes and pieces they're generating in order for the system to work. And there's also a tension with this notion of having some sort of universality in systems so that students aren't being asked to interact with a gazillion different kinds of analytics. So I guess those are some issues that it seems like a basic tension, and I'm curious if you thought about these.
Thank you. Well, I think one of the inspirations for our current work in the Learning Dashboard project is to make a single system as interoperable as possible so that a student who may be working in one learning environment for a part of a course and having multiple different technologies at their fingertips, all of that data, even across courses, could be bubbled up, integrated into one analysis system. And I was talking to someone, if you think about Western Governors University, for example, a student there is not going to be necessarily adopting one online course environment, but rather the student is going to have to be navigating a pretty complex space. So if we can have a learning analytics system that integrates, I think we could help the student navigate that somewhat, diverse technology space. That's on the student side and technology. You also sort of re-raised the question about if we're transforming learning, we need to transform our teaching as well. And so I do feel that tension a lot because I play my role directing the teaching center. So I'm going to be an optimist here, and you can shoot me down, and we'll see how it goes. But I think there are two things that make me optimistic. Number one, I think faculty are worried, and they're feeling that if they don't change, they may be left behind. So if there's any kind of pressure that might be a positive, in a positive direction, I think it's potentially now is the time to leverage that. And I've always said, the 10 years I've been at the teaching center, that technology change is the foot in the door to real pedagogical change. So a faculty member might come in and say, oh, I want to try this new toy, this new whatever it is, ed tech thing in my class. What I'll say is, okay, why, what problem are you solving, and how is this technology going to help, and how will we know if it helped? And we end up getting into really deep issues about student learning. So I'm optimistic that these changes in technology will get at those deeper issues of teaching and learning as well. I had another reason for being optimistic when you were first asking that question. I'm trying to remember it. I'll come back to it. Thank you. It's a good one, though. It's a very good one.
Gregory Dyke, University of Lyon. I was wondering if someone comes up to you, actually it says on your webpage, get in touch with us and get your own dashboard started. And so I imagine there are a bunch of things that actually need to be put into place for that to work. So there's, I don't know whether you mentioned whether you only have rubrics that are based on existing tests which map fairly well onto skills, or whether you also detect things automatically where you're inferring skills, and then whether the skill model needs to be robust in a kind of LearnLab definition of a robust skill model, or whether it can just be any skill model. Basically, and then there's probably other things in the workflow that I haven't imagined. Which of these things are hard, and which of these things are necessary to get right for learning gains to happen?
So, as someone mentioned, one of the Achilles heels or whatnot is to do that skill map, and I think that is the first step. We do have methods for doing that in an automated or semi-automated way. I have done in some recent work comparisons of when the skill map was not so good versus a really good skill map. How much sensitivity do the results have to that, and then how much sensitivity do the learning gains have to that? And it was kind of a glass half full, glass half empty kind of message there. So at least I can say that making effort to improve the skill map does lead to improvements, but the bootstrapping approach that we've been using seems to be one that may be workable. So starting with a basic skill map that's pretty adequate to capture the learning trajectories in a content domain is probably good enough, because as the course evolves, we can pinpoint where it needs to be improved. Those are the key. I think that's really the key thing, is to think about the skill map, and depending on what the technology is behind the learning resources, then just to think about instrumentation.
Okay, my name is Jeroen Donkers from Maastricht University. I have a remark and a question. The remark is first on a former question about soft skills. And we work in medical education, in the specialist training. And well, we're not talking, mostly the time, not talking about skills, but about competencies. And we use a lot of different workplace-based assessment instruments to measure skills. And we have a portfolio system in which we collected those measurements. And we plan to apply learning analytics on the basis of that. So we do have more or less quantitative and qualitative information about soft skills. So that's just a remark. My question is about course design. I don't know whether you know the instructional design method is called 4CID by Jeroen van Merienboer. It's a method in which you design tasks very precisely in complex learning. And in his design theory, tasks are separated in task classes of increasing complexity. And within each task class, the tasks are ordered from high scaffolding to low scaffolding. And I'm just wondering, in your system, how do you deal with tasks of different complexity and tasks having more or less scaffolding in them?
So one of the things that is a part of the skill mapping process is that we can capture not only the fact that a skill is exercised in a given instructional activity, but the degree to which it is exercised. So the most straightforward way to account for more and less scaffolding in the exercises, or even a complex task that has a lot of this skill and a little of this skill, is to keep in mind that the skill mapping is not a binary map, but a continuously valued representation, and that any given instructional activity can map to multiple skills. And so this is sort of a weighted profile. So I think that would be the most natural way to approach that. It is the case that even without scaffolding, there is a range of difficulty levels, and oftentimes it is that the difficulty is a function of the student having maybe not less scaffolding, but having to engage new skills that were presumed or supported by the scaffolding. So the most common one I found in my research is the skill of recognition and selection. So what oftentimes makes a complex task difficult is not the actual steps you have to take and doing those all correctly, but in recognizing, because it's a contextualized problem, what strategies or what knowledge should I be bringing to bear? So in this case, our system would account for that by having the competence of recognition and strategy selection is something that's new in the complex task that was formerly not required. And so I think that's actually really important for instructors to recognize, because what you can do is you can have a unit test and a unit test and a unit test, and then students get to the final exam having done well on each unit test, but then on the final exam, when they have all these tools in their tool belt, but they've never had to think about which one goes with which problem, you can have difficulties there. So making that explicit, that recognition and selection is something students need to practice and can get feedback on, it's very useful. And this is where I think something like these kinds of tools can inspire faculty members to recognize, oh, you know, my students are having a lot of difficulty here. It's because of that identification selection skill. I need to put more practice on that skill early. I've tried to promote that faculty members have problems where the students just have to make a plan. They just have to figure out what knowledge is relevant, what strategies are going to help them, and then stop, force the students not to go further, and give them feedback on that, and value, and give them points, you know, whatever it takes to make that planning process an emphasized part of the instruction.
Okay. My name is Julian from South Korea. My home is not being shared, so you don't have to worry. Yeah. My question is a little bit technical. You told me that you told us that you thought the statistical model that you used was a Bayesian hierarchical model. Was there any standardized procedure or to select your model out of other competing models? I mean, there could be many different statistical models. So wasn't there any criteria for the selection, or did you actually compare your model or statistical model with other competing models?
So I have a yes and no answer there. So we have always focused on the Bayesian hierarchical format for our approach, but within that we have done and are continuing to do model comparison and model selection and evaluation studies. So in this approach, we're looking to see what is the best formulation of the Bayesian hierarchical model for efficiency and robustness and things like that. So we're doing a lot of evaluation within this space, but mainly within that space.
Hey Marsha, my name's Miles Danson. I'm from JISC in the UK. So my question for you is around benefits and business case, and I was struck right at the start of your presentation this morning that you were very upfront and you gave us that lovely quantitative line about less than 50 hours, 18% improvement. Fantastic. So my question to you is, fictitiously, say I'm a chief exec, you want some investment from me, you've clearly attracted a good deal of investment to produce this system. What are the benefits? What are the key performance indicators that you're tracking here beyond that 18% improvement?
Good question. So there are a few things, actually. So I think learning gain, pre-post gain is one that I've already mentioned. What's alluded to in there is also with the number of hours is efficiency. So one of the things that we've seen in a lot of field work in cognitive science and cognitive psychology is that in real situations, it's not always possible to show one learning intervention is better in terms of learning gains than another, but you may find that one intervention is more efficient. So what we've looked at and what we've continued to follow is the students' time and how efficient they can be, but also the instructor's time. So thinking about this from the point of view of a benefit, if we have students who can, even if they're not doing better after this intervention, if they can be more efficient so that they can learn the material in half the time, then that would be a benefit. If, though, however, the instructor is spending 5 times that amount, we also need to consider that. So we're looking at the learning gains, the instructor time, the student time. Just to give an example of how time can change, this is a new model, right? So if we have an estimate of how well students have learned this week's topic, we don't need to any longer assign a problem set with 20 problems to everybody. That's not the criterion of mastery. Rather, it could be that you only need to do 7 of those problems and you've gotten coverage of all of the material and you've gotten enough mastery to show that you're done. So all you students, you're done. Maybe I'm working on it and I've done those 20 problems, but there's still this area that I need to work on. Now, if I were not informed about where my difficulty areas were, I might do more, but I might do more in an unfocused way. If I need to do more than the 20 problem homework assignment, but I can do those extra problems just where I need it, that even though it's taking me a little bit longer, on average it's taken the class a lot less, and everyone spent their time in sort of the most targeted way possible. So I think that would be the other thing. The other benefit that I'd like to make part of more of our overall utility function is students learning to learn. So I think it's another metric that we can include here, and I think researchers who study this can help us communicate to investors that even all else being equal, if we can improve students' lifelong learning, their metacognitive skills, in that we would be already really winning the day.
That's brilliant. So we've got, I think, 3 there on efficiencies, yeah, and that final point, which was a nice one on, on ongoing learning and benefits to society, and presumably improved opportunities for business, repeat business with universities, which are great. I'm going to really push you now, if I may, Marsha, and say, what about student attrition? Have you seen, can you say, since introducing this system, attrition rates have improved to this extent, and there has been a cost saving to the university of?
Yeah, so my work at Carnegie Mellon, we do not have high DFW rates. So that's not the most sensitive measure for me in my current work. But in some collaborations I have with institutions that have these big gatekeeper courses where they're actually spending a lot of money with students going through most of the semester and then dropping. I mean, that's an inefficiency right there. So I think those are other metrics. I mean, I might broaden it to not only can we make an argument that we're reducing these DFW rates, we're increasing retention. We could make an argument that we're increasing students' perseverance in the field. So one of the big problems today is students' perseverance in STEM fields. So if we could make the connection that when students have these strong start in these gateway courses, if it allows them to be more full participants in disciplines where they're otherwise not well represented, that would be great. And this is sort of getting back to the, how is learning transforming today? I think if we can take advantage of using the computer for what it's good for and helping students in a lot of the ways that our my group's work and a lot of our work is doing, then I think the opportunity for tying that into more project-based work, more collaborative learning would be a way to bring the best of both worlds together. And so if we could even use measures like how much has this enabled us to get authentic tasks into the curriculum? I mean, those would be some, I'm just brainstorming now, but those would be the kinds of things I would hope that we could be looking to.
Okay, hi Marsha. I'm a student from RWTH Aachen University. So basically I have a small request, a small question, and a small remark.
Okay.
The request is where can I get a demo of your system or just the videos you presented in the presentation? Are those available somewhere so I can take a closer look at them?
We've been looking to put some demo up on our site, and I can put these things up there too. So I will.
Okay, thanks. Now the question, because I'm a student and I do most of my learning actually offline on my computer. So I do a lot of coding, I do a lot of reading on it, and I do a lot of writing on it. And this data or this usage data that I produce, have you thought about, collecting it in some ways? Because it still can be collected, but it's not. And my remark is basically, I have a notion that data analysis leads current research what kind of questions it can answer. But I was thinking, what if we first ask the questions or ask teachers or students what kind of concerns they have, what kind of ideas they have, what kind of problems they have, and then try to design the data collection methods, try to design the data analysis method to answer these questions instead of just living in this big data bubble that leads the research into the wrong direction, in my opinion.
Well, I definitely subscribe to how I would call this is top-down and bottom-up kind of processes to get at a really good research space. So the bottom-up processes are using the data we have, more data-driven approaches. But as you could see from my third point, being mindful of the user's needs and really making those questions driven by users' questions would be the top-down. And I think if we have this interactive sort of dialectic, we can really make good headway. So I think that's a great way. And as I alluded to before, I think we should be involving the students more in terms of what are their challenges, what are their issues, what are the opportunities that would really be the biggest bang for the buck on their side. So I think this is a really good way to think about the problems.
Hi Marsha, Simon Buckingham-Shum from the Open University. So I think I, like many other people here, are really interested in how we think about what you're doing, which relatively few people are doing at the moment because of it's new and it's labor intensive to prepare the materials and the skills mapping and the cognitive models, etc. How we relate that to other pedagogies, other kinds of analytics, which are being talked about here as well, which are getting at other kinds of learning processes. So in my mind, I guess this is more of a comment, but I value your view. There are three ways of thinking about what you do in relation to other stuff that goes on in teaching and education. One is you are simply able to accelerate the acquisition of skills that would otherwise take much longer, so that frees up time in the curriculum to do other stuff. To do an authentic project inquiry, to do a collaborative task, right? It's not fair to say, but Marsha's stuff doesn't do discourse analysis or analytics on collaboration or 21st century skills, because you're offering us one tool, and it's a hammer, it's not a screwdriver and a plane and all the other armory of tools that we will have in our toolkit increasingly. So that's one way of thinking about it. You simply free up more time to do other kinds of stuff that many people say are important, right? The second approach is, wow, we can get deep insight into the mastery of these well-defined skills, and now we've got all these other analytics techniques. If we can track that user through those spaces as well, we're building a richer and richer set of lenses onto that learner. And we may start to find, in the joyous world of big data and unified identification of learners, that what goes on in the space of learning algebra or statistics has some interesting correlations with other things that go on, right? That's just a sort of exploratory big data paradigm. And then the third one, which I think you've alluded to, which I found quite intriguing, is to what extent can the techniques you've developed be extended into other softer areas, if we want to call them that, competencies, 21st century skills, by, and I just, maybe that's the one I'd like you to just to comment on, you know, that you know, can we imagine the kinds of techniques you've been talking about being extended into professional development of teachers talking to each other about their practice, or informal social learning, or a collaborative project where people are doing a lot of talking, and we're interested in the way that they're talking and using language. So more of a comment, but thank you anyway.
Well, it's a great way of summing up the points of connection, and I do think those are all good opportunities. In terms of the third, I think that the more we can, sort of ties back to the first, I think the more we can get instructors and students sort of speaking the language of competencies and outcomes, and also the components, skills, and components of knowledge that feed into them, I think that will be a nice path for professional development. What I think is another opportunity is to look at the systems that you're all building for data mining, and to see if in the hidden layers of your model, if there is some human processing of those higher level variables, or if there's some inspection into that system that could be translated to either to the users more directly, or to the scientific modeling and explanation of the features that the data mining can discover. I think that would be another way of integrating across the two perspectives. Thank you.
Thank you, Marsha. I'm going to drive this session to a close, I'm afraid. When I'm either the speaker or the audience members, these are the sessions that I like most. Actually, when I'm organizing it, I hate these sessions, because now I think there's at least 10 people who will be very angry with me. I didn't get to ask my question, and neither did I get to ask my question. So I hope you enjoyed it. I didn't, but okay, that's fine, because it was all about learning more about Marsha's work. So thanks again, Marsha, for doing it. And we have another coffee break for 20 minutes. We end a little bit late, but we start 12 o'clock sharp. 20 minutes from now.